Hello everyone, welcome to Partners DSA. So today we will be covering the course schedule problem from lead code. So let's quickly go through the question. There are a total of courses you have to take labeled from 0 to number of courses minus 1. You are given an array prerequisites where prerequisite I equal to A of I comma B of I indicates that you must take a course B of I first if you want to take course A of I. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. So we can think of it like a directed graph, and if the cycle exists in a graph, then it will be impossible to complete that course, and if no cycle exists, that means we could easily complete that course. So there will be only two solutions. If the cycle exists, the course can be completed and we can return true, and if the cycle doesn't exist, we will be returning false. So we can quickly go through these two examples to understand the concept. So in example 1, we can see the number of courses is 2 and prerequisites is 1 0. That means there are a total of 2 courses to take, and to take course 1, you should first complete course 0. And we can easily complete since course 0 is not dependent on any other courses. Now let's go through the example 2. Here the number of courses is 2 itself, and the prerequisite is 1 0 and 0 1. That means for completing course 0, we should for completing course 1, we should first complete course 0, and for completing course 0, we should first complete course 1. So that is kind of like a cyclic graph, and we won't be able to complete it since both are interdependent. So in that case, we will return false. Now this algorithm is called Kahn's algorithm, and I will explain this concept using one such example. So here we are taking the number of courses as 4, and this is our graph, and it will be 1 0, 2 0, 3 1 and 3 2. That means for completing course 1, we should first complete course 0. For completing course 2, we should first complete course 0. Then for 3, 1 should be completed first, and for 3 again, 2 should be completed first. So let me quickly draw the graph. So these are our nodes. Since we have the number of courses as 4, we have node 0, 1, 2 and 3. And if we go through our prerequisites, we can see that for completing course 1, we should complete course 0 first. That means we can go from course 0 to course 1, and it will be a directed graph from 0 to 1. And similarly, for completing course 2, we should complete course 0 first. That means there will be a graph from 0 to 2. Now for completing course 3, there will be a connection from 1 to 3. That means after completing 1 only, we could go to course 3. And similarly, here also, if we check the prerequisite, after completing 2 only, we will be able to complete course 3. So this is our directed graph, and if the cycle exists in this directed graph, that means we won't be able to complete all the courses. But if there is no cycle, if we look at this case, we can go from 0 to 1 and 0 to 2, then 1 to 3 and also 2 to 3. There is no dependency on any other cycle, or there is no loop. There is no such loop that exists in the cycle. So that means that we should return true in this case. And so for solving this problem, we will be using Kahn's algorithm. So it's kind of like an in-degree method, and for each node, we will calculate the in-degree of that node. That means the in-degree is simply like a count of how many prerequisites is required for that node to get completed. So if we look at node 0, we have in-degree as 0. For node 1, we have in-degree as 1. That means after completing 0 only, we could reach node 1. Then for node 2 also, we have in-degree as 1. That means after completing 0 only, we could reach node 2. Now if we look at node 3, we have in-degree as 2. After completing 1 and 2 only, we could reach node 3. So here the in-degree will be 2. Now what we'll be using is a queue data structure. So I have created a queue, and I will insert all such nodes where the in-degree is 0. So in our case, we can see that the 0th node is having an in-degree 0. That means we don't have any dependency on any other nodes for completing the course 0. So 0 will get added. To keep track of the number of courses we have taken, we need one more variable called counter to keep the track. So here, since we have taken the code 0, we will increment the counter value to 1. Now we will check whether we can add any more nodes to this queue. And if we check over here, node 1 is having int degree as 1, node 2 is having int degree as 1, and node 3 is having int degree as 2. So there are no more nodes, and we can't add more nodes into this queue. So here we will take this node 0 out of this queue, and for every course that is dependent on node 0, we can decrease the int degree count by 1. So if we check over here, we can see node 1 can be reached from 0, and here we can decrease the count of 1 by 1. So we now the int degree of 1 becomes 0, and we can add that to the queue. Now again, if we check, 2 can also be reached from 0. That means we can decrease the int degree of 2 by 1. So int degree of 2 will also become 0. So that can also be added to the queue. Now while adding to the queue, we should also increment the counter. Now our counter value has become 3. Now again, we will pop the element 2 out of the queue, and we will check whether there are any dependent nodes from 2. So we can see that 3 is dependent from 2. Since so we will be decreasing the int degree count of 3 by 1. So it will become 1. And if we check, there is no node that is having int degree as 0, and 1 is already added. Now we will pop 1 out, and we will check whether there is any node that is dependent on 1. So there is 3 that is dependent on 1. So here also we will decrease the int degree count by 1, and the int degree of 3 will become 0. So that means we can add 3 to our queue, and in that case our counter will increase again by 1. That means the counter has become 4. So at last, what we do is we will check whether we have taken all the courses. So we can directly compare the counter value to the number of courses, and we can return. If the number of courses is equal to the counter value, then we will be returning true. And if the number of courses is not equal, then we will be returning false. So I will explain one scenario where it will return a false case. So this is one such case where we cannot complete all the courses. So let me quickly explain this example. So we can see the prerequisites will be 1 0, 2 0, 3 1, 3 2, and 2 3. So a cycle exists between 3 and 2. So if we check the graph, this will be our directed graph, and for 0 the int degree will be 0. For 1 the int degree will be 1. For 2 the int degree will be 2, since from 0 and 3 we could reach 2. And for 3 the int degree will be 2, since we can reach 3 from 1 and 2. Now what we will do is we will push all the elements to the queue that is having int degree as 0. So if we check over this graph, we can see 0 is having int degree as 0. So we will push 0 to the queue. And then we are not having any more nodes having int degree 0. So we pop this element from the queue. Before popping, we will increment the counter, since we have taken the code 0. So we will increment the counter over here. So since we are not having any more nodes, we will pop this element from the queue, and we will decrease the int degree of all the nodes that are depending on 0. So for 1 the int degree will become 0. For 2 also the int degree will become decrement by 1, and it will become 1. So we don't have a graph from we don't have a directed connection from 0 to 1, and we will add all the nodes having int degree as 0. So we are having 1 with int degree 0, and we will increment the counter. So now the counter has become 2. Again we will check all the nodes. We will pop this element from queue, and we will check which all nodes can be reached from 1. So if we check over here, we can reach 3 from 1. So that means we will decrease the int degree of 3 by 1. That means the int degree of 3 has become 1, and 2 also has become 1. Now if we check over here, we are not having any more nodes that is having in degree as 0. So that means we can take 3 without taking 2, and also we can't take 2 without taking 3. So if it so we will be exiting from here since we can't add any more nodes to the queue. And at the end, if we check the counter, we can see the number of courses is 4, but the number of courses we have taken is 2. So we can't take all the course when there is a cycle existing. So this is the logic behind the Kant's algorithm. Now let's quickly code it. So first we need to prepare an adjacency list. So for that we will be having a list of integers, and our variable name will be adjacency list. So it will be new array list. Now we need a queue variable for tracking the courses that we have taken. So it will be queue of integer equal to new linked list. Now we will be preparing the adjacency list using the function build adjacency. And to this function we will be passing the number of courses and also the prerequisites. So we can create this build adjacency function. Public, the return type will be list of integer, and for build adjacency function we have the input parameter as int number of courses and int prerequisites. Now coming to this function, we can create a temporary variable in this function equal to new array list, and we could return adjacency list. Now what we will do is we will iterate over the number of courses I plus plus, and to this adjacency list we will add new array list. Now we will be building the adjacency matrix. So for that we will be iterating over the prerequisites array. 0. Plus plus. Now we have read here that after completing, so in this from this example we can see that to take course 1 we need to complete course 0. So there will be directed graph from 0 to 1. So our adjacency list will be like adjacency list dot get prerequisite of I of 1 dot put dot add prerequisite of I of 0. So that means there is a graph from 0 to 1. Now since we have built the adjacency list, we can return it from here, and we need to calculate the in degree. So for calculating in degree we need an array of size n. For each node we need to calculate in degree. So we will be creating an array of size and number of courses, new int number of courses. Now for calculating the in degree, we will be iterating over the prerequisite array. So we'll iterate over the prerequisite array. So from this example, we can see that the in degree, we should increase the in degree of the first index. So we'll be incrementing the in degree array based on the first index, prerequisite of I of 0 plus plus. Now we have calculated in degree. For that, let's fill the array of in degree with 0. Okay, so now we have got the in degree and also the adjacency list. Now we need to calculate the number of courses that we can take. So we will create a variable count to keep track, and we will first iterate through our in degree array. Int I equal to 0, I less than in degree dot length I plus plus, and we check whether in degree is 0. In degree of that particular node is 0. So if it is 0, we can add that to the queue, and also we can increase the count, since we can take that course without depending on any other. Now we will iterate over the queue. We will iterate until queue is not empty. Is empty. Now we will take that node and we will find the adjacency list of this particular node. So we will iterate over our adjacency list. Adjacency list dot get node. Now we will decrease the in degree of this particular neighbor by 1, and we will check if the in degree of this neighbor has reached 0. If it has reached 0, that means we can take this course and we can add that to the queue. So we will add that to the queue, and also we will increment the counter. Now once all this step is completed, we can directly check whether our count equal to number of courses. So if the count is equal to number of courses, it will be returning true, and if it is not equal, it will return false. Okay, we have some compilation issue, and at q dot add of I. Okay, so here instead of I, we should add the neighbor. So on submit, it got accepted. So our time complexity will be the big O of number of nodes plus number of edges, and also the space complexity will be same, big O of number of nodes plus number of edges.